In this video, we want to find the interval of convergence for the following power series. So we have 7x to the nth over the square root of n. And the way we're going to do this is by using the ratio test. So we look at the n plus first term over the nth term. And then we'll be taking the absolute value of this thing. Okay, now we can rewrite this. So we're going to put the 7x to the n plus first over 7x to the n, and then the square root of n over the square root of n plus 1. Now this simplifies. 7x to the n plus first over 7x to the n is just 7x. And then I could just put the square roots all in 1, like this, n over n plus 1. Okay. Now, the 7x does not depend on n, so I can just pull that out and I take the limit as n approaches infinity of the absolute value of square root of n over n plus 1. So we know that this limit is going to 1, and we want this to be less than 1. Right? So the ratio test says the limit has to be less than 1 in order for it to be convergent. So that means that if I divide both sides by 7, I have the absolute value of x is less than 1/7, which means x is between negative 1/7 and positive 1/7. So now we just need to test the endpoints. So let's first plug in negative 1/7 into the original problem for x. So if you have 7 times negative 1/7 is negative 1, so that's negative 1 to the nth over the square root of n. So sum from n equals 1 to infinity. And this converges by the alternating series test. So we will be including negative 1/7. But then for 1/7, we plug in x equals 1/7. We have 1 to the nth power over the square root of n. And we know by the p-test, this diverges. So we will not be including 1/7. So now to put this in interval notation, our final answer is negative 1/7 to positive 1/7.